Okay, today we're going to prove trigonometric equations. So we have two examples here on the board. We have secant x minus tangent x sine x is equal to cosine x. And we have number 2, secant x sine x over tangent x plus cotangent x is equal to sine squared x. Take note, when proving trigonometric equations, first thing is always change the function to sine or cosine. That is the first step. Change the function to sine or cosine. Now, in these two examples, we only need these 4 identities. So I write the 4 identities here in order for us to be guided as we continue with our proving process. Now, secant x. Secant x is 1 over cosine. So we'll change that 1 to 1 over cosine x minus the tangent x is sine over cosine. So we have sine x over cosine x times, we have still sine x here, so you have sine x over 1. Okay? Continue with the process. 1 over cosine x minus sine x times sine x is sine squared x over cosine x times 1 is cosine x. Now, they are two different, this is two fractions, and we call these similar fractions because they have the same denominator. So, proceed. 1 minus sine squared x over copy the denominator cosine x. Take note, 1 minus sine squared x is an identity. 1 minus sine squared x is equal to cosine squared x. So cosine squared x over cosine x. Take note, cosine squared x is just like cosine x times cosine x over cosine x. So we can cancel cosine here and cosine here. So we come up with cosine x. So we have proven the equations that secant x minus tan x sine x is equal to cosine x. Okay, number 2. Let's proceed to number 2. This is more harder. Okay? Much harder. Secant x sine x over tangent x plus cotangent x is equal to sine squared x. Now, secant x, tangent x, and cotangent x, we have to change that one, these functions, into sine or cosine. But first, we'll focus first on the denominator part. Okay? So tangent x is sine x over cosine x plus cotangent is cosine x over sine x. Now, we cannot proceed on adding these two fractions because they have different denominators. So we will change their denominators in order for their denominators to be equal. So we are going to multiply it by 1, or we have cosine x over cosine x here, and this part here is sine x over sine x. Sine x over sine x is 1, cosine x over cosine x is 1, so we didn't change the function because we multiplied it by 1. So sine x times sine x is sine squared x over sine x times cosine x is sine x cosine x plus the same thing, cosine times cosine is cosine squared x over sine x times cosine x is sine x cosine x. Now this time, the denominators are the same, so we can proceed with addition. Copy the denominator, sine x, cosine x. The numerator is sine squared x plus cosine squared x. And look at the numerator. This is an identity, and that is equal to 1. So we'll change it to 1 over sine x cosine x. So this is the denominator part. So let us proceed to the numerator. Okay, we'll continue. The numerator, secant, we will change the secant to 1 over cosine. 1 over cosine x times sine x, right? Then over, we copy the denominator. So we have 1 over sine x cosine x. 1 times sine x is sine x. So we have sine x over cosine x times 1 is cosine x. The denominator is 1 over, copy, sine x cosine x. These are two fractions. Divide into fractions, get the reciprocal of the divisor, then proceed to multiplication. So we have sine x over cosine x times, the reciprocal of this is sine x cosine x over 1. Now we can cancel one cosine here, another cosine here. So what is left is sine squared x, because sine x times sine x is sine squared x. So we have proven that secant x sine x over tangent x plus cotangent x is equal to sine squared x. That's it.